What's up, math scholars? We're here with first period, and they're looking really tired, but hey, I'm excited. There's lots going on this week. We have, you can sleep in tomorrow, air testing. We have connection scheduled Wednesday, and then Friday I'm not here, so hey, it's going to be a great week for me. I don't know about you guys. Hey, who's excited for the study guide today? We got our cell phones put away and our earbuds out, and we're ready to be scholars today, right? Alright, I already told everybody in class, but on the back of the study guide is the formula sheet you'll be given Thursday, so familiarize yourself with what's available. So, for example, converting from degrees to radians, is there anything on that formula sheet that can help us out right now? What, Zoe? No, well, I don't think the unit circle is going to help because 275 degrees is not a stop on the unit circle. Nice try. Anything else that would help us? Good, John found it. So for 275 to go from degrees to radians, you're going to multiply by pi over 180. So we'll have 275 pi over 180. You can either have the calculator reduce that fraction for you, or you can reduce it by hand the long way. Oh, I knew that would happen. So if you want to have the calculator reduce it for you, go 275 over 180, math, enter. Don't use the pi button. The pi button is irrational, cannot turn into a fraction. So it's 55 pi over 36. All right, number 2. If theta is an acute angle of a triangle, I'm going to just go ahead and sketch myself a acute triangle to have a handle on what's going on. If cosine theta is 3 over radical 58, find cotangent. So cosine, if you remember right, cosine is adjacent over hypotenuse. Our adjacent side is going to be 3. Our hypotenuse side is going to be radical 58. Radical 58. Looks like if I need cotangent is the opposite of tangent, so it would be adjacent over opposite. We're going to need to solve for the third side, okay? So how do we solve for the third side of a right triangle? Pythagorean theorem. Let's just call this x. So 3 squared plus x squared would be radical 58 squared. Hopefully you know what's going to happen over there with my 58. The squared and the square root are going to cancel. So it's just going to be a 58. Over here we'll have 9 plus x squared. So we can subtract the 9 over. Won't that be 49? And square root it. So what's x going to be? 7. Cool. Yep. So tangent would be 7 over 3. So cotangent would be 3 over 7, adjacent over opposite. All right, let negative 4, 6 be a point on the terminal side of an angle. So basically they're saying that's living on a circle. Not the unit circle, it's way too big for that, but it's living on a circle. Negative 4, 6. Do you know what quadrant I'd be in before I give away the spoiler? Nope.
2.
Quadrant 2. If I lived in quadrant 3, Logan, that's my negative quadrant. So I'm living up here. I'm going negative 4 this way, 6 this way. So probably live up here, negative 4, 6. Now what I need to do, though, is draw in a right triangle and label the triangle. I would have gone left 4 and up 6. I'll draw that bigger in case that's too small for you to see. All right, you should have no trouble seeing it now. It's 4 left and 6 up to get to that coordinate on the circle. You seeing it?
Yeah.
And the theta would live right here. Oh, this is actually easy. I don't think we're going to have to solve anything, are we? Isn't tangent opposite over adjacent?
Yes.
So we should probably be able to answer it right now, huh? What's the opposite side? What's the adjacent side? And I'm guessing if it's a multiple choice question, that would be reduced down. So go with 3 over negative 2. Divide the top and bottom by 2. Hello, people in the video. We did some board buddies on this. It's called Heron's formula for when you finding area of a triangle when you know side, side, side. You want to start by finding S. And this is on the formula sheet on the back page if you look for it. But you start by finding S, which is actually called the semi-perimeter. It's half of the perimeter. So you can see my group finding the perimeter right here and then cutting it in half. That S value ends up being 16. Then you're ready for the area formula. It's the square root of S times S minus A times S minus B times S minus C. So we ended up square rooting 1280 and getting 35.77.
Yeah.
All right, these groups came up, looked at their unit circle. They were looking for all places in quadrant 1 and 2 that would have a y value of 1/2, so it's 30 and 150. Good work, scholars. Oh, yeah, we can do this as board buddies.
Math scholars don't.
Hey, math scholars, we're here with a young little whippersnapper student. She's a freshman. We won't give you her name. But anyway, so we're talking about a section of road having an 8% grade. That means it rises 8 feet for every horizontal 100 feet. Could you label where you think the 100 would go if it's a horizontal distance? Nope, horizontal. That's diagonal.
I don't know.
Horizontal. Good choice. All right. Now, if it's rising 8 feet, where would you think that would go? There we go. So you see it? It's going 100 horizontal and 8 vertical. We're trying to find the angle theta where it meets the road. Take it from here. All right, we had a lot of trouble with this problem. A lot of board buddies, people have the wrong answer, or they ran for their seat before they were done. That happened with them. But labeling it is important. It's a horizontal 100 for every vertical 8. And then we use tangent. So we had tangent theta equals 8 over 100. And we had to use tangent inverse. So in my calculator, I typed in tan inverse 8 over 100. It's 4.57 degrees. I didn't think that was as hard as these people made it out to be.
It was.
All right, we'll just do the next one together because it's very quick. If cosine is positive and sine is negative, that's why how this is saying. If cosine is greater than 0, then it's positive. If sine is less than 0, then it's negative. What quadrant would we be in?
4.
Very good. So down in quadrant 4, the x values would be positive, the y values would be negative. This is a quadrant 4 one.
Thank you.
Number 8. We'll just do it together. Look on your unit circle and see if you can find 3 pi over 4. If you can't find it, we'll have to convert it. But I think you could probably find it. All right, they did locate it. It's at 135. I always try to get myself into degrees because I think in degrees better. Now, do you remember how reference angles work? It's been a week or so.
It's like, and then it's like 180.
Right, Zoe remembers. So she goes, the reference angle is going to be right here. So we're going to have to do the 180 minus the 35, and then that's going to be the reference angle. So what do we think it is, 45? That's correct. The reference angle would be 45 degrees, right here. Logan's a scholar. So that was helpful because 3 pi over 4 was on our circle. If it wasn't on the circle, you just convert it. Yeah? Oh, yeah. Thank you. Now my video will be accurate. All right, this one was quick and easy. Our board buddies did a great job. 22 pi over 3 got multiplied by 180 over pi. The pi's went away, and it ended up being 1320. Let's find cosecant 60. We'll just do it together. So first of all, cosecant is the reciprocal of who? Is it the reciprocal of sine or the reciprocal of cosine? It's the reciprocal of cosine. So what I would do is I would find cosine of 60 and then flip my answer. So what's the cosine at 60? What's the x value at 60? On your unit circle. It's 1/2, and then we would flip it upside down. So I believe my answer would be 2 over 1, or 2. Is that okay? Actually, I messed up. Cosecant's reciprocal of sine. I was having a Monday problem. I wasn't using my brain. Is that what you were going to say? Yeah. Thank you. As soon as I said it, I thought about it. So cosecant is actually the reciprocal of sine. Just because it starts with the C actually means it's the reciprocal of the opposite. So find the sine value at 60 and then flip it. So it's going to be 2 over radical 3. Now I'm just going to leave it like that. If you want to be a real scholar, you would rationalize it. That's probably what they're going to make you do next year. So to rationalize, you multiply by radical 3 over 3. 2 radical 3 over 3.
Whoa.
The one on the test doesn't have a radical on the bottom, so you don't even have to worry about that. I like to rationalize from time to time to show you what a pre-calc teacher would make you do. I think if you're headed to math studies, they're not going to care about rationalizing, but pre-calc, they care. Why are you doing pre-calc? Is that what you said?
It's recording.
Oh. All right, negative 120. You can either look for where negative 120 would live, or you could do that plus 360 trick. So where's it live? 240, Logan just said. So let's go ahead and find 240 and do tangent. Tangent is y over x. Where's my unit circle? 240. The y value would be negative radical 3 over 2. The x value would be negative 1 over 2. And we did that on that little unit circle quiz, and not everybody reduced their tangent down. To reduce your tangent down, it's a negative over a negative, which would basically turn to a positive, and then these can go away. So it's just going to be radical 3.
Whoa.
That's fine. All right, we are going to consider triangle TYL. I'm definitely going to draw that. I don't attempt problems without drawing things. TYL, in which L is 20, TL is 4, TY is 3. Make sure I labeled that correct. I always ask myself, is it a right triangle? And if not, do I have a complete set of partners? It's clearly not a right triangle, but do I have partners?
Yes.
I do. So probably use law of sines. It says, find the measure of angle y. There might be more than one solution. So we'll have to do our law of sines and see if more than one answer would work or not. So here's the partnership I know. 20 goes with 3, and then y goes with 4. That's weird because my 4 kind of looks like a y. Sorry about my bad writing. This is a y. This is a 4. All right, remember our keystrokes for our crisscross applesauce? Multiply these two, divide by this one, and do a sine inverse at the very end.
Whoa.
4 times sine 20. Divide by 3, and then do a sine inverse for the last step, second sine, previous answer. So I got 27 degrees, but since we did a sine inverse, we have to consider the supplement of 27 degrees. So 180 minus 27. And I'm going to ask myself, would that obtuse angle be too big for the triangle or not? So is 153 too big for this triangle? Could a 153 go here? 153 plus 20 would be 173, so that'd be fine. So y is either 153 or 27. The board is shaking.
The board is shaking?
Mm-hmm. Look at it. It looks like it's shaking to me. All right, well, if you watched the video, thanks for watching. We're going to stop here so we have time in my other classes and finish up the rest tomorrow. Goodbye.